All right, let me cancel this. All right. So this is the beginning of the Git Intro meeting, finally. And what I wanted to cover was why we use Git and how it can be useful for a lot of people, and then demonstrate the different pieces of Git. There's some things I'm just not going to cover in Git, but that can be covered later on. But I want people to be able to at least use the basic functionalities of Git. So why we use Git? Git allows us to version control our code. And the way that works is you create a repo, and then as you work on your code, you commit your code. Think about it like stepping stones in a pond. Each time you commit code to your repository, you store a snapshot of the code, and that allows you to say what is different between this commit and that commit. And the other thing is the Git information can be pushed or pulled from the copies of the repo to other copies, which allows you to do collaboration. This is how GitHub works. When you do GitHub, you have a copy of the repository on GitHub servers, and you have a copy on your local server or a local computer. And so what will happen is you do your work, you commit your code, and then you push your commits up. Well, they can pull those commits down to their copy, and they have the same history and the same information. So the other thing is every single Git repo that you have is a copy of that repo. So if I pull down your code, I have a copy of your whole complete history of code. And that means I have a backup of your code. So what that allows you to do is you could push to GitHub or GitLab or whatever, and let's say your computer dies, you still have your code out there accessible, and you can reclone it and get it back. So that is why we use Git and the purpose of Git. Now, to get Git running on your computer, you need to run this script. What this script will do is this will install a couple tools, and I'm working through Git through a GUI. Git is really command line, but to show the processes without learning command syntax, I'm going to use Git Extensions to do a GUI run through of Git. There are only going to be a couple commands we actually run, and the rest will just be done through the GUI. The GUI will generate the commands for us. So if you don't have Chocolate installed, you need to uncomment that line and only run these two lines in an admin PowerShell instance. Once you do that, you will then run this set of commands in another admin instance. And what it will do is it will install Git Extensions, which has a dependency on Git, which means Git will be installed. This will install the PuTTY software. This will install the P4 merge, which is a merge tool, and then GPG4Win, which is a tool we use to do Git signing. And I'll talk about Git signing later on. So if you haven't run that, you can go and run that and deal with that, but and that's in the meeting event paste bin. All right. Oops. Okay, so covered that. So when you have Git extensions running, which I already do, and I'm going to have to open a repo just to get to the specific setting, but let's see. Let's do this. So this is actually the repository for this tool itself. And so you can see the history that I was talking about. Each time a commit is made, you have the different work. I just recently submitted a fix for, I opened a designer in the thing, and then Visual Studio had a crash. I fixed that error and got that pulled into their repository. Talking about that later. But what I want to do is I want to get into the settings. And under Git config, and we have this set up for global is going to be your user account that is so that all repos get this setting. Local for current repositories lets you set settings for only this repository, which allows you to do things like I have a work repo that I pull down and I want to do a little work on it. I clone it down, and then but I don't want to commit as my personal email address. I want to commit as my work email address. I can configure it and say my username is, still J. Asbury, but my work email address here. If I did that, then and I actually put in my email address, when I commit, it would actually say I did this at this address. So local and then effective will show you what is currently effective for this repo, so that you can see, okay, global is here, and then it's going to let local overwrite and effective, so you can see the combination of what the settings would be. If you change effective and there's no local, you're changing global, which is something that I've been bit before, so you got to watch that. But I'm going to clear this out because I don't want local for this just yet. As you can see, global, I have my personal email address and my email address here, but you just set these two fields. Every commit that you create has an author and a committer. By default, the committer and author are going to be the same. So, but when someone else commits the work but says I did it, that's where you have author versus committer. So as you can see, Igor did, or Rusky did this commit, which this was actually a rebase. He took mine and rebased it into the master, which and then so he created a new commit, but the author got set to be me. And so they know who did the work, but who actually created the commit. So the way you run in the command line, you run git config. As soon as it starts up, come on. There it goes. So if you run git config -- global and say user.name, you will adjust the global username. So the settings that you set, you're running git config in the background. And so when you alter these settings and go to the config, you're really running git config -- global or not, or local, not -- global, and you're just altering the different settings. So that's what's happening when you change these. All right. So to configure Git, you have to set your username and email address. Diff merge tool, it's really good to set this up. Now, I'm going to use P4 merge, and I'm going to show a merge conflict later on. But again, when I went into the config, you'll notice that the setting that I set was for P4 merge, and it's for both the merge tool and the diff tool. This tool is more for showing what's different between X commit and this commit. Merge tool lets you do three-way merging between what existed already and two different commits. And that's when you deal with merge conflicts. And so I drop this down, pick P4 merge. It defaults to, but you can say, I have it installed somewhere else if you need to. And then you can click suggest. When you click suggest, it will automatically fill in the command line for you. Do the same thing with your diff tool. Browse in just in case it's installed somewhere else, and you hit suggest, and it will fill in. Of course, I've already done this, so it's already going to be the same. So when I hit F3, it'll run the diff tool. When I do a merge conflict, it'll run the merge tool commands, passing in the right information to those tools. The next part is to configure PuTTY. PuTTY is an SSH client, and it lets you do secure shell connections, which is the best and secure way to get information back and forth through your to the GitHub or GitLab or other remotes. So the way you configure it is you generate or import a key. So notice I set this to be RSA 2048 bits, and you can hit generate, and it'll generate key, and just move the mouse and it just to generate random data. There's my new key. And you want to save your private key off. And this key needs to be secured. So when you do save it, you do want to give it a password. And so here's where you set this up. So you say key passphrase, and 1, 2, 3, 4. Of course, that's not secure, but we're gonna this is gonna be temporary. Save private key. And just for now, to make it easy, I'm going to go to downloads just because I don't really care about this at the moment, but put it somewhere. And intro key PPK. Hit save. So I have generated an SSH key, a PuTTY SSH key, and it is set up to. This public key information is what you will want to copy and give to wherever. You can also save the public key off as a file. If you have a current existing open SSH key, you can convert. You can also export this key as an open SSH. So you can go back and forth. But you can import key, find an existing open SSH key, and create a copy of that key as a file. So which you can research open SSH versus PuTTY and learn that. But the main key is you need to have a PuTTY key, because the way I've set it up is when you install PuTTY, install Git Extensions, it's going to use PuTTY. And, oh, right, almost forgot. So under settings, if you remember correctly, I told the install script to install PuTTY. And when you install PuTTY, Git Extensions doesn't know where that is. So here's where you tell it Git Extensions is going to use PuTTY, OpenSSH, or other SSH client. So you want PuTTY, but you need to browse and say, where is plink, where is PuTTYDen? So when you installed PuTTY through the install script, you need to change these paths to say where are plink, puttygen, so that when it needs to run those tools, it knows where the path is. So, for example, program files. Oops, not reverse. Putty. And there's plink. So it's looking for plink.exe. There's the path of the program I want, and do that for the rest for these three. You need these configured so that when you run these different commands, it will actually work. So when you click Tools, Putty, Start Authentication Agent, or Generate Import Key, it will run the right tool. So again, I can load a private key and look at it and either like re-export it with a different passkey or do whatever I need to do. So here's the intro key I generated earlier. What's my password? 1234. And there it is. And then I can copy this again. I really wish they would make this easy to copy, but you can say a public key, just a, and again, intro key, intro, public key. And just to look at that, that's oh, I know. Come on. Open with code. Visual Studio Code is a really good editor, but as you can see, so that's what you really need to copy. You want to have this whole information. And I'll show you how you would like set up GitHub to do this. What SSH does is it will also say it's me because you only have access to that key. So there's no logging in. It's just your key that says I'm the one pushing these commits up, which also lets you have access to it. So I'm going to go to Settings. Security. Oh, not security. Where? Oh, there it is. Cessation GPG keys. So I've already done this. I've already uploaded my private GPG key. So GitHub knows my SSH key so that when I push up to GitHub, it knows it's me sending the information up. My GPG key, which I'll demonstrate and work about setting up, is the signing key, and I've generated that, and you can also generate it straight in here, but it's better to have a copy of it locally first. And that's my preference. And you can learn how to generate here, but I'll show that to you and work with GPG later. But this SSH key now knows, so when I connect using my SSH key, it knows it's this user. And so the way you load an SSH key is to go here, key, and so this is the, if you notice the watermark, it begins with SSH RSA. So it's actually this information we want to copy. Yep, that is. Okay, so it is this format. It's the, yeah, that's right. It's the, there's different formats of exporting keys. This is the one you want. So you want to copy from the public key information here and not the dash begin key and key format. So you would do this, give it a name, say, hey, intro, SHH key. So this key now has access to my GitHub, which I'm going to delete in a second. If you had my private key information, you could use this and connect to it, and you would be saying that it's my account. So I'm going to delete that because I don't want that key attached to my GitHub user account. All right. So that is configuring SSH and working with. It's a one-time setup pretty much, and for each key. But once you've done that, all you have to do is point it to the right key in the repo, and it'll work. So covered generating, importing. You can import a key from OpenSSH and convert it. So if you have an existing key, I want to use the same key, you can import it. Git signing. The reason why we do Git signing is, as you saw, when I went to settings, and went to Git config, you saw that I can say I'm anybody. So I could look in this repo, go and say, I am Bill Gates, and I could say Bill Gates at Microsoft.com. Obviously, I'm not Bill Gates, but each commit would generate that data. So there's no trust in that. There's just, I configured to say I am Joe Schmo. That's a problem. So the way we get around it is we do signing. And so I'm going to cover setting that up. So one of the things that we installed was GPT-4Win. The program that you do to manage the keys is Cleopatra. And eventually, there it goes. Why are there two? Oh, weird. And it takes a second for it to load the keys and everything, but it looks like it started 2 instances, which is really weird. Alright, we're going to shut down one of them. There we go. That's better. Alright. So I have other keys, but I'm hiding them because I don't want those keys to show. But this is my key that I generated. And I have actually uploaded it to the key server so that people can certify it and say, hey, it's me. But let's generate a key. So you hit new key pair, create a personal. You don't want to create an X509 because that's creating a certificate, which is a little actually more secure, but the issue is you have to wait for a CA to generate it. You might have to pay for a certificate. We're just creating a general personal OpenPGP key pair. It's important that you enter this to be the same information that you want to sign as, because you want the commit to say J. Asbury, my personal email address, and you want the signing to say same information. So make sure you use the same information that you would use that you used in Git config to say my username is and my email address is when generating this. So, for example, let's say I am tester, and I'm going to be 123@123.com. Hit create. And again, you want to secure this. Now, again, 1, 2, 3, 4, because this is only be temporary. Hit OK. It will tell you if the password is done. Are you sure, or do you want to enter a new one? Yeah, I'm sure. When you secure it, use a secure password and not just weird one. You can upload, but you should create a revoke key first. So if you ever find out that your key got given out and you don't want that key to be correct anymore, you need to be able to revoke it. So I'm going to hit finish, and I'm going to type in test. There we go. There's the key I just generated. Go to details, and oh, it's not in more details. It's export, I think. Oh, there it is. Sorry. Generate this. You need to generate this revoke certificate. This certificate is going to be a thing that you use later on and revoke it. You can learn about how that works. I'm not going to cover PGP stuff, but you need to have this available before you upload it, because you need to be able to say this key is no longer valid. I'm not going to generate this because I'm not going to use this, and I'm not even uploading it. This is just going to be local and temporary, so I'm not going to do it, but you should. After you have generated the revoking certificate, excuse me, after you generate the certificate, what you need to do is you need to upload it to the server. You can hit publish, and if I hit continue, it would send it up to the public key server. So people could actually search for that email address or that name and find that key. Again, I'm not going to do that. You should. This way, you can have key signing parties. You can say, I know that that's his key, and I can certify that it is his key, and then there's a level of trust involved in that. If you saw my Gmail and go to details, certifications, you can see it's been certified by my work email address and so on. So that is generating a key. Now the information that you need to tell Git is the key ID. Now they don't make it easy to copy it here, but look at the key ID value here. It's A3EC. But if I use test, and you can see that key ID. If you go to details, it's the last two of the fingerprints. So if you copy that information and get rid of the space, that is information you need to copy to send to Git. So I'm going to copy that, Control-C, close, And we're done with Cleopatra. That was just, you just need to get that key information there. We'll use that in a second. When you installed GPG4Win, as you can see in this picture, you see where this is where I browsed and verified that GPG program is there. So you're going to run global GPG.program and quote and that path. You can also copy from Explorer that path and then paste it in. So you can go something like this and say, actually navigate to that folder. Oh, right, it was x86, I'm sorry. GPG. Then GPG. Hold down Shift, right click on GPG, and you can say copy as path, which is right here. It only shows up when you hold down Shift. It will not show up if you don't hold Shift when you right click. But you say copy as path. Oh, dang it. Well, whatever. All right. I guess I'll have to. All right. So quote that path, and if I ran that now, I've already configured mine, but this is the path to the GPG program. You need to tell Git where is the GPG program to run. I've already run that, so I'm not going to run that. I'm already configured. The next key, configuration is where is the key. So you would use user.signing key. Then you'll put that key ID. Remember that key ID that I copied? I would paste that here. So I would go here, details, last two, copy, paste, get rid of space, and that would set my global signing key. I don't want to do that because that's my global signing key. I want to use my personal for my global. If I get rid of global, it will say only for this repo. So I'm going to do that. I'm going to say when I commit, it will use this tester key. You'll see how that works in a little bit. By default, your commits will not be signed. To make that happen, so there's me running my key and running that config. This is me setting the path to the program. Oh, oops, I forgot that one. Let me modify that. All right, so the command to run there is, let me get there. Let's see. I love Markdown. All right, here we go. This works. Finish. Git config global oh boy, it is GPG commit. That's right. going to have to look at this. Make sure I have it right. Should be commit that signing, but I want to make sure I sign. I don't want to give you the wrong command. It is. There it is. GPG sign. Commit.gpg. Actually, I'll just paste it. True. And let's copy that. Let's put that in my notes. There we go. All right, so what this will do is this says, make sure that my commits are signed whenever I do commit. So it will generate the commit, and then it will sign the commit with the key using the GPG program. And that will say this key is the one that's going to sign. And so as you see, I can set the individual repo to use this key. So I can say use my work email in this repo, but then any new repo I create by default use my personal. That way you can have control over how things work. All right, so I've covered those. You'll see how these work in a little bit. I'm more covering setup and configuration right now. You'll understand how these work in a little bit. All right, save that. There we go. All right, so let's actually create our repo. Now, I've created a folder called Git Intro. And have certain things in here, but I want to create a repo against this and actually track the stuff I've been doing. So I'm going to create a new repo. A personal repository is one that actually lets you check out the files, and it's a full repo. Central repository is more like what GitHub does. They create a bare repository that only stores the repository information and doesn't check out files. They don't need to check out the files. They just store the information in there. So we want to do a personal repository. Most of your repositories that you create on your computer are going to be personal. Only if you want to store like have a Git server where you push and pull to the repository, do you want to create a central or bare repository? So if you remember, you saw the folder and it didn't have the .git folder. I just created that, and that created the initial Git repository information, and it has certain files. That's where your Git repository lies. Everything you do in Git is stored in these files and other files that you create that get created through doing Git operations. So now we have an empty repository with no information. It's initialized, but it doesn't really have anything set up for it. Oh, shoot. I'll fix that later. All right. So the next thing I want to do, I did set the sign key, didn't I? Okay. Okay, so I want to run this. I'm going to yank that on my Git Extensions repository because I don't want to use that key when I commit and Git Extensions. But I'm going to use that key here. Now I have modified. If you look at this, sorry, I'm going to tickle. All right. So I can run edit, and I can see what's in the config file. So it has some basic core stuff like when I created the repository, this is the version, and is it bare, and things like that. But notice I said user signing key, and so it created the user signing key value. So you can configure local, this repository only settings, and then you have global that say for all repositories do this. So I don't have to set my merge tool, my diff tool on every repo. So now that I've configured this repository to use my new SAC, a new GPT key when I sign, the global says commit, when I commit, you sign, and I set in global where the program is, it will just work. Before you do your committing, the first thing you need to do is you need to create an ignore file. The reason why you create an ignore file is you do not store generated output of your, so like if you're doing a Visual Studio project, you don't build the project and commit your executables or your DLLs and the stuff in the bin folder. You don't commit things that aren't things that you use to generate the output. You only commit those things. You don't commit your temporary files. You don't generate. You don't commit your databases. The database that you in SQL Server, you don't commit the SQL Server database files, because if you have one in the local folder, because SQL Server is probably going to have a lock on it. You don't want to try to commit files that are locked because it may not be able to read it, and it'll just go, I can't get access to that file right now because it's being used. So first thing you do, you edit ignore. By default, you have nothing. There are a few different ways to do this. Git Extensions has built up a default pattern that covers a lot of things by default that should be ignored, that if you do this, you should be covered by default. So we click Add Default Ignores, and it describes the different things that, if you have the ReSharper extension, if you have, the .vs folder that Visual Studio creates, the packages folder when you use NuGet, all these different, anything asterisk.obj, anything in the bin folder. Now, something to know about Git is Linux-based. It's case sensitive. So if you have a path that is lowercase bin and there's a folder capital B bin, it will treat those as different. So you have to use file globbing to do case insensitive. So this is what this is doing. This is saying capital B or lowercase b in will catch a lower or uppercase bin folder. Same thing with the debug folder. The slash at the end just says it's a folder, it's not a file. You can do a little research on git ignore files. Another way to, instead of typing in you can type in here and enter in whatever information you want here. But if you work with this, you can go and say, for example, I have some markdown files. I can say asterisk.md. And it shows you what it would match. So this is a useful tool to figure out what am I going to ignore, and if I do put this pattern here, what will it hit? And I'll just add that line to this file. These two links here are So awesome. Generate a custom ignore file takes you to a tool that has been created that lets you search for different Visual Studio Code. So if you're using Visual Studio Code and you are on a Mac and you are doing Core, let's see, I think .NET Core. So if you're doing .NET Core on Mac OS in Visual Studio Code, here's a good Git ignore file to work with. Copy that, place it in the editor, and away you go. So now, of course, I'll not work on a Mac and everything, but that tool is really good for finding what would be good to ignore stuff based on what you're doing. Another resource is this example ignore patterns. And this is a repo of ignores based on what are you working on. So, for example, if you're working in Dart, if you're working on Delphi, Eagle, Java, whatever. If you're working on Ruby and Rails, Haskell, JBoss, you got people committed these files and said, "Hey, you never want to commit these files when you are working on a repo with this system. When you're working on a Qt in Linux." So you have all these different things, and so you can go into Swift. Here's when you're working on Swift. So Objective-C and Swift. Here's your ignore file to work with and say, I don't want to have these files included. Use your Git ignore to not ever get files you don't want included in your repo to begin with. Here's why you do that. Let's say that you have a little short video you recorded introing your program. And let's say it's 5 megabytes. Real short video, 5 megabytes. Each time you record a new intro, and let's say it's roughly 5 megabytes no matter what, each time you commit a new instance, that's an added 5 megabytes to the repo because it stores every copy of so when you clone the repository down, if you did 5 intro videos and you committed each one, that's 25 megabytes that it has to download because it has to download every single copy. So what you do is you only include source code or only things that you need to work with your source code. Things like your application icon, that's fine. Things like resources that are build scripts and things like that. Yes, include those. Don't include things that your program downloads, for example, or anything in the bin folder. You don't ever commit your output. They can pull your code down and compile and generate the output. You don't need the output or things that the program pulls down from a website or anything like that. All right. So create repo and set the ignore. All right. So let's do a commit. Save. So you'll notice in Visual Studio Code, I have a new file, Git ignore, and I have other files. Now, it knows that there's, if I hit refresh, Yeah, okay. Yeah, so see how it's saying that it's untracked? Hit refresh. You see that it thinks there's nothing being tracked, which is true. So I'm going to go to Git Extensions, and I'm going to hit commit. And I have a picture that details with my meeting, that is the Explorer window, and my, yeah, I don't need that. And you can do a lot of different operations. I don't need this picture. I was just testing that functionality. All right. So this markdown file right here is my meeting notes as I've been doing, and let me make sure I have that saved. I don't. Okay. There we go. I want to commit this and store it as, yes, this is the current copy, current version. Do I have any markdown issues? No. Awesome. Okay. So I'm going to stage, what I'm doing when I'm committing is you have your working directory, which is the actual folder where your Git repository sits and all your work. The index or stage is what will be committed if I currently hit commit now. Notice I have all these files. So I'm staging these files. Well, I actually want to start with committing the ignore file. So as you can see, I can stage and unstage files and say, what would I want to commit? So this one, I'm going to create a commit. Oh, right. Notice the committer is my personal. And I didn't want that to happen. So, because remember, I set the sign-in key to be tester. So let's go and change that. So local for this repository, I can say tester 123@123.com. All right, so you notice the committer is now tester 123@123.com. If you want to change the author, it's a format, it's author, then in angle brackets, the email address. So if I want to say John Smith 125@123.com. So now the author will be John Smith with a capital M 125@123.com, and the committer would be my tester at 123@123.com. So I don't want to do the author bit just yet, so I'll just clear that. All right. So every commit has to have a message detailing what did I do in this commit. Git Extensions lets you set up commit templates. You can pull down a history of recently used commit messages, so that if you need to rework a commit, you can pull back that commit and not retype. And you can also create branches, which I'll cover branching later. So you can do, so if you're in the middle of committing, you go, oh wait, shoot, I need to do this. You have a lot of control over what you're doing. But here's your commit message. There's something called the 50-72 rule in Git. You want your first line of your commit message is the subject. It needs to be short. It is not a long-winded description, you need to say, I did this. And it needs to be an active voice. Don't be passive. I did this. So, whatever. Updated the main window with new style or whatever. Updated the new style. Not, new style is updated. All right. So it needs to be short. Here's Git Extensions by default. We have configured it to let you know if you've gone too far. It'll be yellow, and the red line is the spelling, but the yellow is telling you you've gone past your 50 characters. Now, it's not, it will not prevent you. It's just letting you know, hey, you might want to shorten this a little bit. If you go over a little bit, it's okay, but try to keep your commits between the subject line to 50 characters. That's the 50 part. You want a blank line. So if you start typing here, again, it will tell you, hey, you don't want a blank line between the subject and the rest of your description. So you need a blank line. Then you can be detailed, but keep this to 72 characters. And that way you can describe your commit information, and it's easier to read on a console, because consoles usually have only 80 character width. This is partially why you have 50-72 rule. It's not a set in stone, you have to do it this way. It's a recommended, this is the way we do things to make it work and easier to read and easier to work with. So it's okay to be a little longer, but try not to be. So in this one, I want to stage my ignore file, and I want to describe it and say, add git ignore file. Hit commit. And there's my key. See, tester, 1, 2, 3, and so I remember it was 1, 2, 3, 4. All right, so I created the commit. By default, you are on the master branch, and you can see that tester123.com authored the commit. Here's the hash. When was it committed? It was committed 26 seconds ago. You can copy different pieces of this if you want to give out the hash to someone. Say, hey, check out this commit, or you want to copy the message, or you want to copy the author, or the date, or whatever. You can copy the information. You can copy. If you have multiple branches point on this commit, you can say master or whatever list of branches are there. So what have we done? We have set a point in time in this Git repository, and we've stored the files off to the repository folder so that it knows this file was, at this point in time, this way. Let me show you what happens if we edit the Git ignore file and we change it. So let's delete a couple lines, and let's say cat. And if I hit commit, Git ignore is listed, but it's edited now. And you notice it knows I removed those lines and I added cat. That is why we use Git. You can do this with all your code, and then that way you can verify and know what has changed. I'm going to go to the diff and see and the diff here is, well, this file was added because I never, it was an empty repository and I added the file. So the difference is the file was added. So all the lines are new. I can hit F3 after clicking on this file and open up P4 merge. Which takes a second because, oh, come on. Oh, right, there is no diff. That's right. It's not gonna. Yeah. All right, it's not going to show it on the added file just yet because I'll commit this and then I'll show you the resetting in a second. So let's say I staged. One thing I meant to cover about committing. Now there it goes. I was just taking sweet time. So you can see the diff and see these lines were removed and this line was, and that's the difference. So notice I can actually select lines in this staging and say stage. I hit S. So you can stage, you can reset, you can do, oh, that's new. Okay, but stage selected lines and reset selected lines. So if you look, Git Ignore is currently saved this way. And I want to go and reset and say, no, I didn't mean to make that change to the packages line. So I'm going to click on that line and hit R. So you want to reset this, change it to like, now that depends on where you are when you hit R. If I hit R when I have this selected, it's going to reset the whole file. If I click in this and have that be the active control, it'll only reset that one line. So I just reset packages, so see how packages is not a difference anymore. Well, if I look at the Visual Studio Editor, see, packages line is back in. So before you commit, you can stage or undo changes straight in the commit window. You can say, oh no, I revert that change, fix this, make it right. And so now I want to stage. Now, here's what's staged. So it is going to commit those two lines. It will not commit the removal of the line and replacing it with cat. If you notice it's red and then green, that's a modification. I removed the content in the blank line and replaced it with cat. It's an easy way to understand that. So if you see your red and the green right underneath each other, you modify the same line. So what the staging does is I can say, let's say you detail commit. Let's say I did, don't need to ignore these, whatever. Oh, ignore, there we go. So I could commit this and store that as a thing. Now, I don't want to track or commit anything I just did to Git Ignore. I actually want the Git Ignore to go back the way it was. If I stage something, I could reset just of those changes and say reset. And that reset the whole thing. It reset the whole file. And if you notice, I'm back to where I was. So you can stage lines, you can stage files. It allows you to control how that works. And it's okay, there it goes. So let's see. Yeah, I got that. I don't know why. Oh, it's just a painting issue. Okay, got it. There it goes. That's weird. Okay, so I'm going to pause for a second and let's. Does anybody have any questions about this or feedback on, like, I didn't understand this? Oh, great. All right. I'm going to take my notes. I've covered committing, taking files, messages, the 5072 rule. All right. So the way the stashing, what a stash is just a local copy of your changes that you want to store back and restore to your repository later on, but you need your working directory to be clean until you are ready to commit again. Stashing is right here. My working directory is not clean. You can see I have 3 files to commit. If I hit commit, you can see that I have picture, the install script, and the meeting notes so far. Now, I'm going to commit the meeting notes first, just because I want to store where I am first. Let's see, make sure I'm got that commit. So, yeah. Save. Hit save. Okay, cool. And I'm going to say add meeting notes. Okay, so I want to stash the changes that I have in my working directory so that I have a clean working directory. So that there are times when you need to stash. There are times when you want to pull in somebody's code into a different branch. You're working on stuff. You're not really ready to commit, but you want to at least store what you have currently. Then you want to be able to restore it later on, but you don't want to store it in the Git history, and you don't want to send it off to the remotes when you push your commits off. So that's what stash is for. Stash is like a local commit only. If you just hit stash, it's going to, based on your settings, it will stash some things or all things. That can be fun. So the way you manage stashes, you can control what happens, and you can add a message. So here it says include untracked, which is a default, if I remember correctly. Keep index is the staging area. So if you have things that are staged, so I'm going to apply this stash and put it back in the working directory. And I'm going to remove this stash. Let me show you what I mean by keeping the index. So if I say keep index, you can hit edit, write custom staff message, and say, hey, call my stash, keep index. Oh, right, I need to actually state something. So let's stage the install script. Okay. Manage stashes, keep index, include untracked, and you can stash selected changes. So you could say, I only want to stash this one script, or I can stash all. Stash all will just include everything, which is what we want. And then I can say edit and say my stash, stash all changes. So I created a stash called my stash, and when I close this, it's going to refresh the window, reread the history, and you'll see I have my stash. And why did it? That's weird. Oh, it kept the index. That's right. Okay, so keep index. That's right. So remember, I stage the files and I stash. That keep index means don't wipe out the index, the staging area. So keep what I have staged, but reset working directory. If you don't have keep index checked, your index gets wiped along with stash. So when you stash, your staging area gets cleared out, which can be useful. But that's how stashing works. And so what stashing does is I can delete. So let's actually go in here and reset this file. which means it's actually deleted. But I have the stash. So what if I apply the stash? Remember, my working directory was clean. There was no changes compared to what I had committed. And look, my index came back, and the assets came back. Everything that I stashed got restored. So the last thing you want to do with stashing is you want to be able to drop it. And stash pop is the same thing as apply and dropping in, and this will do it in order. So if you have multiple stashes, this will do it to the last stash you did, which might not be what you want. That's why I go to Manage Stashes and select which stash I want to deal with. Here's my current working directory changes. Here's my stash. You can either apply or drop. Drop is permanent. Once you delete a stash, it's gone. But you have the drop select, which then removes the stash from the Git history. Stashes do not travel when you send them off to remotes. They're only local in this current copy of the repository. So when I drop it, the stash is gone. That way, there are times when you check out a different branch and you have a dirty working directory that it will offer the option to stash. You can tell it the stash, it'll create a stash, then it'll check out the other branch. Then you could have the option to apply the stash to that work. Git makes it really hard to conflict your code by working in it. So it really helps, and so that's what stashing is for. And that's I want to make sure you understand stashing, because that helps you to go and say, I have this dirty state, I want to store it off temporarily. It's just like another term for it is shelving your code. All right, so that's what that's for. Now, what are branches? Well, the main object in a Git repository is a commit. You can see I have two of them in this repository right now. Now, what if I want to create a branch that I describe and say, hey, I'm going to create a console program, and let's see. Okay. Stash, create branch. Yeah. Okay. So let's create one branch that describes that I'm going to say I'm going to create a new project, and I'm going to call it like console app. It's good. It would be great to not put spaces in your branch name. You shouldn't do this. It gets really tricky and pain in the butt. Create your branch names short and sweet, but descriptive enough. So console app like this. If you want to put a space, do an underscore. If you ever need to run Git commands, having spaces, you have to quote it. It gets to be a pain. So make sure you don't do spaces to alleviate any problems. But we typically call it console app and create branch. I think we actually, if I remember correctly, I think we actually already replace it with underscore if I remember correctly. Let's try it. Yep. So if you do put spaces, it will fix it for you. Yep. So I created a branch. The branch points is you have a head of a branch, and the head is the current commit that is pointing to. A commit points to its parent. So if you see the parent of this commit, if I click on the parent link here, it goes to there. So that is the parent commit. So all branches have to do is point to where is their head, which commit are they pointing to. The history of the commit parent will track the branch history. So let's go to Visual Studio and let's create a console app. And I'm just going to create a stupid, hello world thing, but let's just all right. This one's console app VB. Where we go? I know. Thank you. All right. We're going to put it in the Git Intro folder because we want to put it in the repository folder that we have. So. All right, good enough. I'm going to close Cleopatra since I'm not using that anymore. That might be what's going on. No, Codrush was being, but that's what it was. Okay, that's fine. All right, so we're going to do a console write line. Save that. And I'm going to build. All right. Now I have 13 files to commit. Now, I did that on purpose. Cool. Awesome. All right, cool. So, show ignored files. So, here's files in the OBJ folder. Here's stuff in the bin folder, things that I don't want to include. You can go in and say, oops, I ignored a file that I shouldn't. I want to track that one file, but still follow the ignore rules for other things. Ignore is for files that have not been committed yet. Once you track a file, you have to tell it to stop tracking and tell it to remove the file, or you skip work tree or assume them changed. Those are things I'm not going to cover now, but if you start with your ignore file right, as you notice, it's only going to include source code. So let's stage only the console app work. I didn't include that picture for a reason. I wanted to show a feature of rebasing and things like that later. All right, so, sorry, meant to. All right, so only console app folder work. So stage, so these commands make it a lot easier. So you can select the lines, select the files, and then stage only what's selected. You can stage everything. You can unstage everything, or you can unstage the selection if you have files selected here. So I'm going to stage what's selected. And then say add initial console app. Now, it doesn't ask you for the password every time. When you, if you commit within a reasonable amount of time, it will only ask for that password. The key stays open for whatever you can configure that in Cleopatra to say the GPG's key stays open for X minutes. I just haven't committed close enough that so each time it's been asking for the key. Now, master is still pointing to add meeting notes. Console app has moved ahead and gone to, and I've stored a add initial console app branch. Now I'm going to go back to master. And moving between branches is checking out. Oh, actually, moving between commits is checking out. You can check out a branch which says, hey, check out the commit, but also point what my current branch is to the branch name that I'm using. So the way I created a branch was I right-clicked on a and said create new branch here, and then fill in information about the branch. I want to check out master. I can do it either here and say check out master. I can say check out branch and get a dialog, and this is what I wanted to show you. If you have a dirty directory, it should, if you have files that would be modified by checking out, it would ask you. But since I haven't committed any, there it goes. So it says, hey, you have dirty stuff. What do you want to do to local changes? Do you want to stash them? Do you want to merge them in? Do you want to not change them? I don't want to change working directory. I want to leave, actually, right, I want to leave them alone. I could reset, but that would mean all my work would be toast. I could hit stash. I could also say merge. You can play with those and find out what they do, but I'm going to leave don't change for now. So that my working directory stays the same. So it's going to have console app changes. I'm going to ignore those for now, but I want to stage only specific things. So I'm going to commit under master. Now, there was something I wanted to do. When I said add meeting notes, I meant to include that picture. Now, I didn't on purpose this time. So I want to create a commit, but I don't want to move the history forward. I want to actually replace this commit. This meeting notes need to get fixed. So what I'm going to do is, now since I'm currently looking at the commit, I can do an amend. So when I hit commit and I stage the picture, I can hit amend commit. It means walk back one step in history and recommit and point the branch to that new commit. So what's going to happen is I'm about to rewrite history. Rewriting is important, is something that you need to understand, and I will cover later on in a second. But right now I'm going to say yes, and you'll see what this does when I amend the commit. So look what I did. The master branch went, and we've changed where the master branch flows. The parent commit is now the add get ignore file. The next commit in the master branch is this commit. Console app is pointing to the old flow of add initial console app and add meeting. But this add meeting and this add meeting are different commits because they were done at different times and they have different file information. I'm going to show rebasing and merging and all the different branch functionality using this as a step. But I also want to store the install script. So I'm going to create a commit, and I'm going to store add install script. Add tool. No, yeah, add install script. I'm sorry. All right, so my master branch has more of the meeting information. My console app has the console app, and it's branched off. Now do you see the idea of what I mean by branching? You create branches, and you can have offshoots and say, hey, I'm doing this feature over here. You can get the work done in that feature branch, and then if you need to fix a bug, you can check out the bug fix or create a bug fix branch, fix that stuff. You can merge or rebase to get your commits to flow and keep and get that history included in other branches. Before I do anything, I'm going to create a tag here. Tags are another pointer to a commit. It's just like a branch, but it's a point in time. It's a way to it's a named commit. So you can basically tag a commit, and that way you won't ever lose history if you rewrite history or go somewhere else. It's a way to, I always want to track this thing. So I'm going to say before merge. And with tags, you can choose to sign them or not. I'm going to sign it. So I'm going to say sign with default key. I've created a pull request to fix this. It doesn't show a border with text box, but you can type here and type a message. But you can't type a message when it's not a lightweight or annotated or signed. Lightweight is just a regular tag. It will not let you type in message. It will let you type here. It will let you type here. And it'll let you type here. But when it's lightweight, you can't add a message. We're going to sign a default key. We don't need a message, but we're going to say, actually, you know what? Before merge or rebase. Because I want to be able to get back to this commit even if I've rewritten history. All right. So as you can see, I have a tag called before merge and then a branch called console app. Now, I'm done with the console app. I want the console app to be merged in and put it into master. I'm currently in master. I can right click on that branch and I can say merge to the current branch. And since there's two ways, I can say before merge, it's the same thing. It's pointing to the same commit. So I can say merge that branch into master. Do I keep a single branch or do I create a merge commit? Now, it's not going to let me do a fast forward. Actually, yeah, it's not going to. So if I hit merge, and I'll cover what the options do in a second, but let's just see what the merge does. Let me see the idea. All right. Well, so look what's happened to it's merged these two commits and these two commits and created a merge commit that says, okay, your history is now merged, so now you have these changes. If you look at the diff, you can see I basically added these files in master, and I added these in the add install script. This is what's different in add install, so it added the console app. This is what's different in the console app branch. So I don't like that. It's not clean. I want to redo the history so that I don't do this merge. So I'm going to reset master back to here. This is resetting. When you reset, you are changing which commit the branch that you're in is pointing to, which can affect history, and you need, and this is how do we want to affect working directory. Now, since I have everything committed that I need to work with, and I don't need to worry about losing history, I can just do hard. Hard is going to discard all my working directory, and it's also going to reset the index. So nothing will be staged. Is it okay? Oh, oops, I did the wrong commit. Time to show you the ref log. So I goofed, and I wanted to include the install script commit, but I don't see it. Well, Git has a ref log. It stores the history of what it did, so I can get back to that commit. So this is the commit I really wanted to go to. So I can say reset current branch to here, hard, hit OK. Yep, I'm sure. All right, so view, show ref log references. Turn it back off. I don't want to see those right now. Now, instead of, I want to have a cleaner history. I don't want to lose work, but I want to make console app play on top of the current master. So what I'm going to do is I'm going to check out console app. Hit OK. Now this is going to be rewriting history. The console app branch will be changed. I'm going to rebase it onto master. So I'm going to rebase current branch on selected interactively. Interactively lets you see what would it do before before it does it. If you select the first one, it'll just do it. So it's generating a to-do list of what steps it'll do. So it's going to pick the add meeting notes and add initial console app commits. But as you can see, I don't want the add meeting notes commit because that's in my master commit branch already. So I'm going to say you can either just remove the line, or you can just say D. You can see these different options. So you have pick, reword, edit, squash. Those options, I want to. So you can either do this and say add initial. So this is the only commit that I want to add on top of master. Or I could say D or drop, and it would remove it too, but this shows that I want to do it. It's a little clearer to read that I'm going to drop that commit. Save the changes, and it will do the rebase. What this will do is it creates new commits. The commits that I had in console app are going to be gone. Well, the branch is going to be gone. The before merge tag is still going to point to that history. I love that it does that application. There it goes. Okay. So what I do with a rebase, I set the base commit to be that master commit that I right-clicked on, and move the console branch to point to that commit. So now you have a straight line. So I don't have this branched off and then merge this into here. Personal preference. Some people like merge commits. Some people like rebasing. The issue with rebasing is if you rebase to where you've already pushed the commits up to a remote and you rebase so that your history has changed, people are going to have problems when they try to pull their code and merge it in. They're going to have a lot of issues. So only rebase up to where you've pushed it. Don't go below where you pushed it, because if you've already pushed it, and I'll show you what that means later, but the idea is you don't want to just rewrite the whole history or rewrite history that's already been sent out. You want to be able, you can create a revert commit or create a way to say, I'm redoing this or undoing this instead, to keep the history. rebasing is good for cleaning up history that you're about to send to say, hey, I want to, there's something called, a lot of people create a work in progress commit, so WIP. So what they may do is they may do something like this. And yeah, Visual Studio saw a lot of change files, and so, okay, cool. So let's just, I don't know, copy a line, doesn't really matter. All right, cool. Come on, load the project, come on. All right, so, all right, so I created I modified the files, and I'm still in the console app branch. I'm going to commit, and I'm going to stage a file, and I'm going to say, you know, do more work in console app. Oh, do work. Work in progress, WIP. If you see a WIP in commits, it's someone saying, I want to stage and note where I am in the code, but I'm not really done with this. I'm just sort of staging and saying, hey, I'm noting that I'm doing this. And let's do it a couple more times. And we'll do the line staging to speed it up, but all right. Okay, so let's commit this and say, I'm doing this to show the rebasing so that you can see I want to clean up this history, but I got to generate the history first. I've got something running that's killing my speed. It's really weird, but whatever. Maybe I should be in a conference call. All right. So I've moved console app ahead of master, and I've done work. But my work in progress commits, I don't want to show that I've done. I don't want to show that I've done this, then this, then this, then this. I want to create a collapse commit that just says I did some work. So the way you do that is you go back and right-click on master. Now, the commit that you right-click on is the commit that you start from. So I want to start from here because I don't want to affect it. I want to affect up above. So I'm going to start with this one. I'm going to say rebase current branch on. Now I'm on console app branch, and I'm going to interactively rebase this. Rebasing takes a little while to get used to and to understand and to see what you're doing that would affect it, but I'll get to that in a second. So right now, I want to reword this commit because I want to change the message, and then I want to fix up because I don't want to take the message. If the difference between squash and fix up is squash gives you a chance to meld the commit messages, and it'll show you an editor saying, here are all your commit messages. You can fine-tune the message. Fix up says, just push the commit work in there. Don't worry about the message. So here I'm going to fix up these so that it'll create one commit. I'll reword this commit first so that I'll create a new message for it, and then these will play into that and it'll generate a new commit. So I'm going to save that. Okay, so here's my editor, and I want to change the message and say, show hi more times. So that'll show hi more times. And so that will be the message of the commit, and then all the other work will play into it. So I'm going to hit yes. Okay. So look what it's done. The whip commits that I did got rolled into it. Look at the difference. It included all the work I did, but it's rewritten the history so that the console app now has my cleaned up history. Now I can go back to master And since my working directory was clean, it didn't show a dialog saying you need to reset your changes. My history just moved over because it was clean. So let's look at what currently is in that folder. Well, it comes out folder, but only the untracked things are there. So it wiped out my source code. But that's okay. The console app branch still has the work. Remember, I'm checked out master, and master was pointing at this commit, which only has this committed. So checking out branches resets your working directory to that commit information. That dialog that comes up when you have a dirty directory is telling you, hey, you have things in your working directory that you haven't committed. If you reset, you might, if you hit reset, it's going to wipe out your working directory to point to the way it was. If you stash, it will do a stash. It will check out that branch and get the file the way it needs to be. And then it will ask you, do you want to apply the stash? And it will try to apply the stash to the current work directory, saying, here, make these changes. Merge, it will try to merge the changes into it. Do nothing would be, don't change my working directory files. Just point the current, what commit I'm looking at to be that commit and change the branch. But leave all the files like they are in the working directory. So what we're doing here is I want to take console app and merge it in. Now, if I want a clean history where it will try to do a fast forward, which it can do, this is the option you want. If you hit this, it will always create a merge commit, and it'll say, you merged this branch into this branch. Because there's no other history going between master and console app, it will do a fast forward. You can tell it to squash the commits so that it'll create a commit, but it will not show the steps. It'll just create one new, the merge commit itself will just have the changes in it. You can specify a merge message if you want to and say, I did this, whatever. We're going to keep it a single flow. We're not going to create a merge commit. And I hit merge. Hit OK. And you'll see that master and console app will now point to the same commit. Now, one thing that you can do, now, this is another way to do it, but the difference is merge will protect you from certain things. Resetting will not. Once you say, yes, I'm resetting, that's it. And merging, it will go and say, well, wait, you can't, you have conflicts that you need to fix or things like that. That can be handled by, so this is what I mean. When I hit reset current branch to here, I'm going to move my master to point to that commit, which is the same thing as a fast forward. So a fast forward is just to reset up to that branch. A merge commit, so let's do it this way, merge into current branch console app. And this time let's create a merge commit. Hit OK. that was weird. Oh, weird. Okay. So see the difference. Fast forward, it just moved up. This shows I did a merge commit, and it keeps the commits there, and then it says you merged 2 branches into 1. So the difference, and what I meant by resetting, is if I reset this master back to here, okay. So the same thing as merge and fast forward would be branch to here and hard. But this will reset file. The merge commit is a little safer, and I'll show you a merge complex soon and show you why you want to do a merge or a rebase instead. So as you can see, my reset did the same thing as a fast forward. So if you look at the file tree, you see console app, you see console app folder, and you see the things that are being tracked. If you look at diff, you see that I'm changed only module 1 VB and change these lines. If I go to the add initial console app, what files got this file, this commit? These are the files that were modified. So you can do, and you can compare. You can go and say from here to here, what would it take to go from show hi more times to add meeting notes? Well, I would delete all these files. If I were to go, I want to know what changes happened between add meeting notes. How do I get to show more times? I can hit Control and select on those and say I added these files. You can also, so I can click on this one and say go to add install script. So what's changed? I added the picture and I added the install and I deleted these files because this add initial console app is here. How do I get to that commit? The order you select them matters. The other thing is you can also do a compare. Compare. So I can say compare this tag to branch. What branch? And local. And compare to master. So what happened on master? And you can use tools in here to compare them, but this lets you verify and say, well, what changed? How did it change? All right, so let's go back to our meeting notes. I've covered checking out, branches, headless. Okay, so here's this tag. I can check out this commit, and it'll put me in something called a headless state. I will not be on a branch. And you'll even see, it'll say, no branch. And I could even cherry pick this commit, so basically commit on top of this. The problem when you're committing, yeah, that's fine. Yeah, that's fine, whatever. not going to cover cherry picking. That's something you can look up. But I'm committing on top of this, and I created history, and I did create a new commit. But notice there's no branch. There's nothing pointing to that commit. So if I send this out, no one's going to get that history because there's no branch pointing to it. You're just playing with committing stuff to the repository. Pay attention to the fact that you know, if it says no branch, now I can right-click this and create a branch there, or I can create a tag, or I can create something that would point to it and keep that commit around. But if it's not being pointed to anything, so if I click here and say, check on master, for example, well, that commit's gone. Well, yeah, because there's nothing pointing to it. It's still in the ref log, and for a while, you will be able to see it, but eventually, Git will clean it up. So there's the commit. I could right-click it, and I can say, create a branch, do whatever. But pay attention to that. You need to be in a branch to have your history tracked and flowed. Don't commit in a headless state. Rebasing is actually, it checks out that commit and does a flow and then just resets the pointer of the branch to that new flow of history. So that's what it does. Is it puts you in a headless state, does stuff, and then just points the new branch to the new flow of history. So I'm going to take reflog off. All right, so I'm going to cover merging, cover rebasing. All right, so let's do an uncovered resetting. Yeah, I've shown resetting files, I've shown resetting lines, and I've shown resetting commits. Now, let's create a merge conflict. So, take a look at my history. All right. I'm going to create, oh my God, reload the project. Okay. So I'm going to modify this line and master. I'm going to say now there's an extension for Visual Studio, so I can click on this and tell it to commit, and it'll bring the commit dialog up. And modified. Let's do modified. All right. So as you can see, I'm in master. And I'm saying changed in master. Now, I'm going to check out console app. And I'm going to say change in console app. Okay, I'm going to check out master. So I want to merge the work I did in console app and say, hey, I modified console app feature, and I want to pull those changes into master and flow from there. Master tends to be, it should be your, like, that's my production thing. You can have feature branches and development branches and things like that, but master should be your, this is your official, work. So I want to merge in the console app. Now remember, I modified the same line. So it's going to create a merge conflict. And I'm going to try and do a keep a single. It's going to not, wait, yeah, it will not, because it has two commits that it can't fast forward. Conflict. I got a conflict. I knew I was going to get conflict. Unresolved? Yeah, I want to solve them. And remember, I set the merge tool when I told it to set it up in configuration. I told it to use P4 merge and what the command lines. So it's going to run the merge tool here against this file. So I see in the middle, the square is my base, what it was before. And on the right, I have the remote, the console app merge, and then I have the master change there. Oh, man. Well, by default, it's going to take all three lines. It's showing you the changes in the thing and saying, here's your conflict. See, it shows you that you have one conflict here. And the red square is showing you what lines. This, you don't need to type in here. You can, but you can use this to control what lines actually get applied. So I could say, no, just put it back to the way it was. Or I can use the blue and notice the shape. So this will be the one that does master. The green circle is going to be the one that does the remote, which would be the console app branch being pulled in. And I'm going, okay, well, that's great, but instead, let's see what these two, so I can hold down shift and click on the blue and say, okay, got it. I don't like that. I want instead to say, okay, and in console app, so let's copy that and say master and console app and get rid of the okay. So there I've fixed the merge conflict. So now it shows that I modified in master and console app. I've affected the file so that it will show both works. I could choose to override. You can choose how you want to do it, but I'm going to close it and say save. You can commit. Do you want to commit now? For now, I'm actually going to hit no because I want to show you what it did. So I hit commit, and notice it took this and did a it'll create a merge commit of the two commits. So instead of me going and doing this, changing console app, I'm going to click in merge, current branch, console app, keep a single. So you can't merge on a dirty working directory. This is what I wanted to show you. I have to reset my changes. So instead, I'm going to stash it. Master, I'm going to merge console app back into it. It's going to get my merge conflict again. Yep, merge conflict. And this time, now I've already done the merge conflict. I'm gonna apply the stash, but you'll see the same merge conflict that I had earlier. See? So there's the merge conflict. Let's take a look at what I'm gonna not save and say, did you solve it? No. I'm gonna close this. See in the bottom right, it says there are unresolved merge conflicts, resolve. I can double click that and get back into resolving. Now, here's how it does it. It actually does this and get rid of this and knows where the changes are and sees and shows you the conflict information. But that's the what's different and how do we want to do this. So what we're going to do is we're going to apply current stash so that will overwrite the file with the change that I did earlier. No, I don't want to solve any conflicts right now because I already am happy with it. All right. That's not what I want. Oh, got it. Now we should be able to apply it. Hmm. Oh, right, yeah, that would be a merge conflict. That's right. All right, so I know what I want it to do, and I'm like, oh, right. So I want it to be the way I wanted it, which is the new file. So here's my merge conflict. I'm saying, yes, that's the change I want. Save it. That's right. I knew I was going to create another merge conflict. There we go. Cool. Drop the stash. All right. So now, oh, right. I'm still, right. So, merge into console app. Oh, that's right. The checkbox was checked that says didn't commit. So, when I did the second merge conflict, there was a thing that says don't commit, right? So I need to be merging. Oh, that's right. I think that's 30. Okay. All right. So instead of showing you stashing and instead of redoing it multiple times, I'm just going to do it completely this time. It's because I'm stopping and starting again that it's doing this. So let's stash what I have so I can get it back real quick instead of redoing the merge conflict and then go through. I just want to show you the basic pieces of the merge conflict and how to fix it. And and how stashes can really help you in that. All right. So we're going to do a merge, and we're actually going to complete the merge this time. So we do a merge. Hit OK. Unresolved. Merge conflict. Solve conflict now. Yes. Open a P4 merge. And yes, the commit is base. And it's actually, let's see what, let's copy it. Modified in master. This will just help to keep it on track. And all right. I don't want these two lines. I don't even want that line. So I want that line to be the way it should be. So I've modified it and imported changes from both sides into the file, which is one way of is a merge. I'm merging the work into the file so that it shows the fixed changes. So I'm going to hit close. I'm going to hit save. Now this time I'm in the middle of a merge. and solving a merge conflict. So when I hit yes, it's going to actually do the merge, and there it goes. And now I'm ready to do the commit. And it goes, hey, now I can describe it and say, what am I doing? And I'm going to hit commit. One, two, three, four. And now you see, and let me get rid of that stash real quick. I kind of wanted to repeat the process a few times just to show you merge conflict handling. They can get really confusing and really hard sometimes. So I created a commit called change to master in master, and I created a commit in the console app branch called change in console app. I merged those. Well, I modified the same line. Now, if you modify different lines in the same file, merging, it'll just auto merge and go, oh, yeah, here, you got those two files. But in this case, it created a merge to say, how did you change these? And so here, the diff is, against master is this, and the diff, here's the combined diff that says I removed those two lines and added this line. Here's the console app change. So it says changed in console app. And then it went to modified in master and in console app. The change against this commit and the one in master is it got rid of the modified in master period and changed it to modified in master and added and in console app. So you can see how did you change it between these two things, and now my code is merged, and now I have the work done in both branches merged into master, and then you can move forward from there. Merge conflict can get hard to deal with, but once you learn and practice with little easy merge conflicts, going through and solving the merge conflicts gets to be a little easier. And you just have to play with it a few times. All right. Now, I'm going to go to master, and I'm going to commit the work I did in these meeting notes. And so what did I do? I checked all these checkboxes, basically. So I've covered those items. So update what I talked about so far. All right. Now, everything I've done in this repository, Control-Shift-O, while you have the commit grid selected, is stored in here. Everything I've done, all the work that I've done, it's all in here. Here's refs. If I look at the heads and go to the master and look at what the file says, you can see how Git works. Open with code. What is master pointing to? It's pointing to a SHA. which is a commit hash. If I copy that hash and say Control F, actually maybe not Control F, let's just do Control V. Oh, right, there we go. Go to commit, there we go. So I want to go to that commit. It's the one that master's pointing to. So every time you switch a branch to another, it just updates that file and says, hey, master is pointing to this branch is pointing to this. That's all it's doing. All right. Now, what I mean by everything's been local is everything I've done up to now is in this Git repository, and it's not on GitHub, not on GitLab, not anywhere else. So let's create a repository on GitHub. This is an organization I created for this group. And I'm going to create a new repository. And I'm going to call it Git Intro. Intro to Git usage and yeah, okay. And I'm going to create the repository. That just creates an empty repository. It initializes an empty repository on GitHub, and it's going to be a bare repository. And I'm going to copy. Now, this is what I mean by SSH. Remember how I told you about setting up PuTTY and everything? I'm going to copy this URL right here. I'm going to repository, remote repositories, Origin. Origin and Upstream are two de facto names that for remotes. Origin is going to be like your online copy of the repository that other people can reach. Upstream will be a fork. So like when I forked the Git Extensions repository and created a copy of it for my use, Upstream in my repository would point to the one I forked. So, origin, paste, browse. Where is the PuTTY SSH key that I use? Well, I stored it in Google Drive, so it's backed up. I've got it secured with a pretty good password. Maybe not creating them in Google Drive is the best idea, but whatever. There's arguments both ways. This way I don't lose it. I can always reset GitHub to say don't use this key anymore. Whatever. Save changes. And it's going to do a fetch from the remote. Obviously there's no history. There's nothing in it. I've got to unlock it. Notice it started the key. It started the agent and loaded up the SSH for me automatically. So if you include the key in there, you don't have to worry about, oh, I need to start this agent to do this. It just does it for you. You can set master to say, so if I have multiple remotes, I can say which branch goes with which remote by default. So remote repository would be, I want to default to origin, default merge with, which, well, I don't have anything pushed out there yet, so that's not going to work just yet. But save changes. All right. Now, I want to push the changes I have in master up to the repository. So it's going to push. So there's now a new branch on GitHub. And if I refresh this page, you will see the 9 commits. Now, remember how I said that I could set up the GPG key? So I could say the 1, 2, 3. I'm not going to, well, I guess I could do it temporarily. So I can go to settings. Go to SSH and GPG keys. Start. Cleopatra. Come on. I know. It's loading all the, it's unencrypting the keys and doing a lot of, Cleopatra takes a little time to start up and run. It's right in the background, but come on. There it goes. Now, I'm not going to export the I can just copy. So I can go to here, go to export. There we go. That's what I want. So here's my PGP key. Copy all of that. Go back to GitHub, new GPG key. Okay, so now I've added my personal, but it's linked to my, so 123 at 123.com is there, and it hasn't verified, so technically I'd have to go to 123 at 123.com and verify that, so it's not technically verified, but whatever. You'll get an email from them, so that they do protect it that way. So you can't just create a key, and you have to be able to access that email address. But there is that key, and I can go in to commits. Here we go. So it is signed. You can see that I committed it. Apparently there is a user of whatever already, which is really weird, but okay. This commit is, now because I use that email address, it's going to, and apparently GitHub has a user address that uses 123@123.com. It's not verified through GitHub, but it is signed, and you know that that person did the signing. So you see that I signed this commit with that email address, along with the author of the commit is tester, which is tester123. So that's how that verification and trust happens. So it's not verified because I didn't go to 123.com and verify the email address through GitHub, but that's all that is. So I have pushed my work up. And because I pushed the work up, and Git stores everything locally, remember? So it stores a reference of where does that remote point to. Anytime you want to update, you can do a fetch or fetch all to get all from the remote, so like just get all branches that exist. Prune all will remove any references to branches that don't exist anymore. So if I were to push, so I'll do that. Let me push the other branch to it. Actually, let's go over here. So I want to push this way. This lets you push multiple branches at once. So you can go and select and say, I want to push this branch, this branch, this branch, or I want to override it or delete it. You can control it through this dialog. We're going to push the other branch up. Okay, so I have two branches. So I have console app and I have master branch. And I want to delete console app. So I'm going to delete the remote copy of the console app branch. First, I'll show you fetch all. Okay, nothing really update. But look, do you see how origin console app is still pointing to that commit? If instead I do a prune all, it's going to fetch and go, oh, you removed that branch from the remote. And you see how the tracking reference for the remote removed that, so clean that up. So I'm going to push that branch back out because I actually want it out there. Alrighty. So we have this repository out there, and I'm going to commit. I'm going to mark that I've covered remotes and configure adding the buddy key. Branch defaults. Yeah, let's cover that real quick. So now that I actually have the branches out there, you can go back to your remote repositories. Default pulled. So on the master branch, default merge with origin master, so that it knows that if I try to merge the remote branch, it'll go, oh, right, that's linked to your local master branch. Same thing with console app. In console app, I want the default to origin console app. This way, when you do a pull, it will, and let me show you what a pull is. So fetching pulls the commit information down to your Git history so that you have copies of the Git information, but the commits don't move themselves. So let's do this. Let's create a README in master. You can default the create README markdown, commit directly to the master branch. Sure. All right, so I just created a commit that added the README to it. And if I do a fetch all, it's going to update origin master, but master, my local copy, is going to not point there. So you can see where origin master moved up and has a new commit, but I don't have that rolled in. Now I could right click and say reset current branch to here if I'm master, but I just want to pull. And I can pull rebase or I can pull merge. So just like I showed you how you're doing merging and rebasing, you can, but we're going to do a merge. And what it's going to do is it's going to do another fetch, but it also is going to reset my master branch to point to where origin master exists. It was able to do a fast forward. And now my master branch now points to that commit. I always do a fetch all and then do a local merge. It makes it a lot easier. It lets you handle merge conflicts. It's my personal preference. I don't like doing a pull. I like doing a fetch all and then seeing where it was. So if I go and reset back to here, and then I right click on here and say merge in the current branch. Keep a single if possible. Hit merge. It does the same thing as a pull. And with fetching, it allows you to see the history and see what's different. You can compare, look at what's going on without actually updating your working directory, but you still now have the history available so you can see what's coming. What this lets you do, though, set default button. What do you want the default option of this button to do? I set it to be fetch all. That way, it will get any new branches that exist on the remote, and it does it for all remotes. So let me show you how that works. So I want to create a fork of this repository on my personal GitHub. All right. And I'm going to clone it, copy it. I'm going to create another remote. And I'm going to call it upstream. Actually, I'm going to name this, I'm going to call it temp. Can't have the same name. And I'm going to reverse the names of these. So I'm going to hit Save Changes. So origin points to the VB dev to dev, and that is my origin. Yeah, I guess, that would be upstream. All right, so I'm going to call this upstream because I forked it into my personal. And then I'm going to say origin here. No, I didn't save it. That's right. Oh, that's right. Let's call this upstream. Save it. So I'm just renaming the remote and call temp origin. Now the default behavior is going to come into play. So I want console app and master. Now, I just renamed it, so now it's pointing to the upstream information. But you can see that it would go to VB dev to dev. My personal copy, so I can change it and say I want it to go to the origin and change that to origin. Save changes. All right. So now what's going to happen is if I do a merge, a pull, and if I do a pull merge, it would merge the master branch from the remote into that. So that's what that's for. Is setting a default. It will know which branch to go to. And you can change that when you do a merge, but it will default to those values. Now, let's create some work. So I'm going to create a branch. Actually, before I do that, I'm going to do what I said, and I'll cover pushing, pull, and fetch. I covered all that. I basically covered all the concepts I wanted to cover in the meeting so far. I'm going to cover one more, which is pull requests, but then I'm going to be done. So I'm going to save this. I'm going to commit. And I'm going to say, oh, I didn't check that checkbox. Branch defaults. Yeah, there we go. There we go. And just to show you what author would look like. All right. So now you can see the author is me, but the committer is my tester user that I committed as. All right. So I don't have this commit pushed out, but when I push it, it's going to go to origin, which is my VBJ account. Hit OK. So I've done some work on master. I've pushed master up. Origin master, which is my this right here. So look at the commits. You see updated meeting notes. What did I change? I changed those lines. So the commit I just did locally got pushed up to here. But here's the interesting thing. If I go to this repo, I only have 10 commits. I don't have the change I did. Now, yes, I have push capability to both repos, but like someone else who forked this repo wouldn't be able to push into this VB dev to dev. So what we're going to do is we're going to create a pull request. And what we're going to do, we're going to say new pull request. And actually, sorry, we're going to go to the other repo first. There we go. All right, so GitHub shows you this. I can compare the branches and say what's changed. Go, oh, okay, yeah, that's the work I want to put in. I can create a pull request and say update meeting notes from personal copy of repo. Now, you can create a draft one so you can like sort of work with the pull request and then update it later on and then actually submit it later on. But I'm going to create the pull request right now. And you notice it's in the VB dev to dev Git Intro repository. And I'm going to do a review. I'm going to approve it. Actually, no, I'm going to commit. Now, I'm going to do this and say, yeah, I could request changes. And since I'm the author and I'm logged in, I can comment on it, but I can't approve or request changes. If someone else sent changes in, I could approve it or, hey, you need to fix this and submit a review. But I'm just going to say, hey, here's my review. And I can actually hit submit instead of, there it is. And I submitted my review on the work. And so the pull request has, you can actually communicate and collaborate with people. And so once you are done with this and you can say, hey, I like what you did, people who have access can merge your items. I want a clean history. Now, if I had other work in master that moved forward and then I had this work, I could do a rebase and merge to where it would play this work on top of it. This will create a merge commit, so this will show that I'm actually merging this work from the remote repository into the repository. I'm going to show that this time, and I'm going to say merge pull request number 1 from BJ Master, update meeting notes, sure, confirm merge. Pull request was merged. If I go back to GitHub, Git Extensions, I do a fetch all. So upstream shows a merge commit that pulled in this commit into between this create readme and this update meeting notes. It merged those two commits back into it. Now if I reset master to here and say hard, sure. I could also said merge, same difference in this case. When you reset, you do have a chance of losing history. With merge, you're not going to lose history. I know I'm not going to lose history in this case because I don't have any under commits, but it's possible to lose history by doing that. So that's why you need to pay attention to when do you do a reset versus a merge. Do a merge if you're not sure. Now you see how it merged that work. Now I can push and so if I were logged in like on another computer and I pulled down this repository as a different user and only had access to my personal, I could fetch it, and then I wouldn't be able to push to vb dev to dev, but I could push to, and I'd have just origin. I could show and merge that work into and see the history flow. But that's the point of Git. As you saw, I went and did a lot of work and then tracked the changes, and I'm able to show that I did work, and you see different people doing the work. And this allows you to work with other people and push things up and say, hey, here's my work, go review it. Hey, what do you think about this? There are a ton of people that work on this Git Extensions tool itself. There's translators, there's designers. So, and we all use Git to do this. So please learn Git. Please play with it. Please learn how to set it up. If you have questions about Git, please ask in the group. I will be glad to help you with anything and get you to understand or show you how to do certain things. Don't ignore Git. Use it. Use it to track your local stuff. You don't even need to push the remotes. You can, but you're not required to. You notice all the work I did up to pushing up the remotes was done locally. And I tracked the history, and I can keep track of the information, but I never had to push it out. I did so I could show a pull request and show working with remotes and things like that. But you're not required to, but you can also track your work and say, oh, what did I do between this step and this step? Like, for example, I can click on update what I've talked so far, and I can hit F3 and open in P4 merge this diff. Oh. Oh, yeah, file tree. That's right. There we go. So, meeting plan 3. There it goes. Okay, so here I can see the diff and really analyze the diff and look more deeply into a diff through that tool. You can compare things. You can commit things to different branches. You can say, hey, I'm working on this feature X. I can fix this bug. Let me show you Git Extensions again. So under the Git Extensions tool, this is the repository right now, and this is my local copy right now. I don't know if there are any new changes or not. I'm going to hit Fetch All. It's going to hit my copy of the repository, and it's going to hit the upstream Git Extensions copy. So there's mine. It's hitting upstream. Did anyone make any changes? Yep, they did. So it's pulling down new commit information. It pulled down the tag. I've got a couple of different remotes for different people that I work with in this repository. No other commits. So it pulled that, and so it pulled the tag. So let's see what happened. There it is. You created a tag right there pointing to that commit, so that that version is always pointed, so that when we look for version 3.3.1, he apparently just made a release recently. Okay, so that's what he did. He updated, he created a new release on GitHub. So this is the power. So this team, let me show you how many people work on this. There's only 1.4 thousand forks of this repository. And there are people that work on this repository, and there are even teams. See how Artem and then he worked together with him. So use Git extensions to work with it. If you have any questions, ask in the group. I'd be happy to help you out. I hope that this has really helped with everybody learning how to use Git. And that's it.